All right, guys, so here is a class notes video for section 2.4, and then you can check all the rest of your answers to the standardized test prep, recycled mixtures, and the assessment questions in Canvas. Make sure you check your answers. Please, 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 please tell me if you have a question, any confusions. When we're in class, we're going to have a little Q&A session. If you're a virtual student, please send an email to ask any questions that you have. If you don't ask questions, we cannot teach you because we do not know what you do not understand, okay? All right, so first set of class notes is in the upper right-hand corner of that second page of 2.4, okay, so the top of that page. Chemical property is defined as the ability of a substance to undergo a specific chemical change, and the book didn't really give great examples if it gave any, so flammability would be one. Ability to rust is another. So any kind of like reactivity would be a chemical property. Those are things that are specific to a chemical, but also when you test them, you're no longer left with the same substance. It undergoes a chemical change. So if I test whether paper is flammable or not, it's flammable. I'm going to be making something different. The paper's not going to be the same when I'm done. It's going to change into some different substances. So same thing with rusting. When iron rusts, it's now rust. It's iron oxide. It's not actually iron anymore. It's got oxygen combined with it, and it's a new substance. Okay. All right. Something that fits really, really well in this section would be energy changes. We're talking about these possible clues to chemical change, and put a star next to this. This is something you're going to see on your test, your final exam in the spring. These are all the possible signs of chemical change. Okay, transfer of energy, and there's two types of transfer of energy we're going to talk about down here. A change in color, production of a gas, those are pretty self-explanatory, and the formation of a precipitate. Now, formation of a precipitate is when you take two solutions, fluid solutions, you mix them, and you end up with a solid forming. Now, it's not mixing two liquids and you get a rock. It's you're taking a clear solution and a clear solution. When you mix them, you get a cloudy substance suspended in that solution. Okay, so something that's no longer soluble anymore. And that's a precipitate. And we're going to do several labs where you see precipitates form. But we're going to look at energy changes as being either endothermic or exothermic. Okay, endothermic is a reaction that absorbs energy. Now we see thermic, we think heat, and yes, that is one possibility. It could absorb heat. But in this example, photosynthesis, that's a very familiar example to us, having already taken biology. That's not absorbing heat, it's absorbing light. So that's an endothermic chemical process. Exothermic is a reaction that releases energy.
Will you come to the counseling office?
Okay, so sorry about that, but I'm at school, so that sometimes that happens, okay? Exothermic releases energy. Again, thermic could be heat, so fire does release heat, but exothermic means releases energy. Energy could also be light. So fire releases light as well, but so do, like, if you ever have those little glowing stars on your ceiling, those are releasing light. That is a sign of possible chemical change, okay? So releasing energy of any type. All right, the only definite sign. You need to memorize these four possible signs, but any one of these by itself does not mean a chemical change has happened. The only way to absolutely know that a chemical change has happened is that the composition has been tested and a new substance has been found. Not new like it's never existed before, but new as in it wasn't there before you started this process, okay? So a new substance is formed. You have to test composition and see a composition change in order to have that happen. Okay, last little piece here, the law of conservation of mass. This is a perfect way to say it, okay? But you can also say it a more familiar way. Mass can neither be created nor destroyed. So if I ask you to state the law of conservation of mass, you could write it this way, or you can write it the way that was found in your book. And then finally, we have the 3 lesson check questions that you were assigned for this section. So just make sure you check those answers. And if you have any questions on those, please reach out either in class, via email, via Zoom, whatever you need to do, because we need to make sure that you have all the understanding that you need to be successful on your first test. Thanks, everybody. We'll see you guys later.